Let's look specifically at the functions and controls of the Flight Control Unit, which is the subject of this module. The FCU is used for speed Mach control, lateral control, vertical control, autopilot and/or auto thrust selection. Let's take a closer look at these controls. The system can be operated in two different ways, in the selected mode or in the managed mode. In the selected mode, the pilot must continuously select how he wants the airplane to fly: speed, heading, vertical speed. When in selected mode, numbers will appear in the windows under speed, heading, etc. To activate the selected mode, the pilot pulls the desired knob outward. In the managed mode, the computers control the airplane according to parameters previously input into the FMGC through the MCDU. Because the FMGC is controlling speed and lateral navigation, etc., those windows are closed, meaning they are filled with dashes. To activate the managed mode, the pilot simply pushes the appropriate knobs. The altitude window is never dashed because the pilot must always set the cleared altitude. Standard UAL procedure governs the setting of altitude. Notice that the knob actually has two different selectors. An inner ring is used to set the altitude in the window. An outer ring is used to change the altitude increments. The knob increment goes from 100 feet, not too sensitive, to 1,000 feet, very sensitive. Let's start with the speed Mach control area. It comprises a window, a speed Mach push button, and a speed Mach selector knob. The speed Mach selector controls several functions. This is common to all selectors found on the FCU. When you pull the speed knob, the speed shown in the window is the current aircraft speed. You can set a speed in the window by rotating the selector knob. The selected speed is displayed in the window. If you push the knob, the dashes you see in the window mean that the airplane is now in the managed speed mode and is following the pre-planned performance profile. The current aircraft speed can be indicated in either speed or Mach by pushing the speed Mach push button. Their current selection is clearly indicated by a speed or Mach legend on the display. The heading track selector knob also has several functions. It can be pulled, turned, or pushed. If you pull it, the present aircraft heading will appear in the window. If you turn it, the heading track will change. If you push it, it will allow the aircraft to return to LNAV. The heading vertical speed track flight path angle push button is used to change the reference from heading vertical speed to track flight path angle. The current selection is clearly marked by heading vertical speed on the FCU display. Change heading vertical speed to track flight path angle. Heading vertical speed legends have now been replaced by track flight path angle legends, and the current heading has changed to the current track. When in the track flight path angle mode, there is a corresponding change in the flight director display on the PFD. We will now look at the vertical area. The vertical area is divided into two parts: The first one relates to altitude. The second one to vertical speed, flight path angle. Let's look at altitude first. The altitude window always shows the altitude set by the crew. This knob can also be turned, pushed, or pulled. If you push it, the aircraft will return to the pre-planned vertical profile, or VNAV. If you pull it, the pre-planned vertical profile is disregarded. By turning the altitude selector knob, the setting in the window changes. This knob is actually two different selectors. An inner ring is used to set the altitude in the window. An outer ring to change the altitude increment from 100 feet to 1,000 feet. We have already seen the metric altitude push button in the EIS chapter. We will just remind you that this push button is used to display the selected altitude written in meters on the permanent data section of the ECAM system display. The vertical speed flight path angle knob can also be turned, pushed, or pulled. When pushed, it commands a level off. When pulled, it selects a vertical speed or flight path angle. When turned, it changes the vertical speed or flight path angle. However, if it is not pushed or pulled, the window will close after 30 seconds. At this point, we will go to the approach phase to demonstrate the use of vertical speed flight path angle. We have selected track flight path angle, speed 210 knots, altitude 4,000 feet, and the aircraft is in the nav mode. To set a flight path angle value, you must first pull the selector knob. As soon as the vertical speed flight path angle selector knob is pulled, the flight path angle window indicates the current flight path angle, and the aircraft is descending. Note how the 3-degree angle is written, and notice the minus sign indicating a descent. A climb would be indicated by a plus sign. Now change the display to a vertical speed by pushing the heading track vertical speed flight path angle push button. The window is now showing a vertical speed. Notice how the minus 700 feet per minute vertical speed is indicated. There are several other push buttons located on the FCU. Let's take a brief look at them. The Localizer push button is used to acquire and track a localizer. When this function is engaged, green lights are displayed on the push button. The Approach push button enables the acquisition and tracking of an ILS, localizer, and glide slope. It is also used to fly a non-precision approach in the approach nav mode. When engaged, green lights are displayed on the push button. The Expedite push button commands a maximum rate climb or a maximum speed descent. For climb, the aircraft pitches up and climbs at green dot speed at climb thrust. For descent, the aircraft descends at 340 knots with power at thrust idle. The last push buttons on the FCU are the Autopilot and Auto Thrust. Autopilot and Auto Thrust features will be discussed in more detail in specific modules.